All right, so we're continuing in our journey through the longest section of the book in terms of days we take to do it. 6.3, this is day 3 of 4 days worth of lessons, I believe. Today is a thing called logarithmic differentiation. Logarithmic differentiation is pretty sweet in terms of what the alternative would be and how this is going to go. So if you had to do derivatives that had a product rule, quotient rule, chain rule combo, based on the things you know how to do, a derivative like this would be a complete nightmare. Because based on what you know how to do, you'd have to go quotient rule first. So you would copy the bottom times the derivative of the top. And when you try to do the derivative of the top, you'd have to do the product rule. And while you're doing the derivative of the top with the product rule, copy the first times the derivative of the second. The derivative of the second needs the chain rule. And then at that point, you're still only halfway done with the product rule. And therefore less than halfway done with the quotient rule. Like, it would be just incredible. So I don't know who came up with this idea, but it's pretty spiffy. So somebody came up with the idea of just do the logarithm on this side and do the logarithm on this side. Whenever you do the left, you do the right. That seems like that just made that problem probably worse from your point of view. However, and the path we're about to take is not as long of a path as you'll normally need to take. We have a bunch of logarithm properties from yesterday. So logarithm properties from yesterday, when we have one logarithm and there's multiplies, you can make separate pieces that are added. When you have a logarithm problem that's divided, you can make separate pieces that are subtracted. So what we can do for this, and also when we have logarithm things with powers, the powers can go and fall in the front. So what we could do to something like this that has 3 distinct algebra chunks is we could make ourselves 3 logarithm things. These were multiplying, so that makes us add. This piece was dividing, that makes us subtract. This half power would slide to the front. And now, other than the fact that it has logarithm in it a lot of times, which still might be a little unsettling to you because you've only been around logarithms for like 2 days this week, but all of a sudden, those pieces look a lot simpler than the original master giant thing. Questions about how that's split up? So then we do the derivative of this. What were all logarithm derivatives going to make? Okay, so fractions is the magic word I was hoping for. So we're going fraction, 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 fraction. And then what goes where? Say again? Okay, so the original thing goes on the bottom. Its derivative will go on the top. I'm going to do that for now. For this, we get x squared plus 1 on the bottom, 2x on the top. This piece would have x plus 3 on the bottom. Just 1 on the top. And to manage the half, I could go like that. Our original goal was to figure out the derivative of y, which is represented by this symbol. It's not quite alone. How could we figure out the derivative of y if it were alone? Multiplied by y. What does y actually represent? What was y?
Fraction, big thing.
Yeah, that original big fraction is going to reappear in the answer. So the answer will always have the original big fraction and then a bunch of pieces. I'll take a stroll to the left to my open board area, but that's the only example from the book. That's the only example you probably need. I'll do another one, just do it. And you're able to now cut straight to the answer. All the original pieces you saw all ended up on the bottom. Their derivatives on the top. If they sneak a power in, just slide it. So if we take this one on, this would be even more of a nightmare because you'd have, I mean, just 2 product rules, 1 quotient rule, 4 chain rules, just absurd, absolute absurdity. So experience tells me this, and I tell you, and now you have the same experience. You're always trying to do the derivative of y. The original answer will all reappear, and then you're going to get a whole bunch of fractions. And I would just count 1, 2, 3, 4 fractions. 1, 2, 3, 4, fraction, 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 fraction. These are, then do everything from the first fractions point of view. So from the first fractions point of view, these are multiplying, so I'm going to add. This is dividing, so I'm going to subtract. This has the same role as this. They're both dividing. So rather than going parentheses inside of parentheses, they are multiplying each other. So I guess you could insert some parentheses and add. I don't want to do that. I'm just going to do a subtract because from this one's point of view, it's multiplying one of them, so add one of them. But there's 2 on the bottom of it, so there's 2 divides, 2 subtracts. So I'm just going to go like that. And then I'm going to go 2x plus 3 owns a piece of this. 4x plus 6 owns a piece of this. 5x plus 6 owns a piece of this. 6x plus 7 owns a piece of this. My tops, temporary 2, temporary 4, temporary 5, temporary 6 from doing the derivatives of the bottoms. Only a temporary 2, because who else needs to be accounted for? The 3. The 3 would make that 2 a 6. This 4 would make this 4 a 16. The 5 makes our 5, 25. 6 makes the 6, 36. And then in most cases, I'd call it a day. On this, I would address one of the fractions. The second one. What can I do to that second one?
Divide everything by 2.
Divide everything by 2. Every once in a while, you'll sneak into something like that. Something there. I should have done this at the beginning, but I'll add this on now. Just to add to the absurdity. And it'll take 2 seconds to adjust the answer. In the original world now, all of that stuff is to the half. So that's all that would do. Right? If I wanted to now cube that whole problem, all that cubing would do if I sprinkled on a bunch of pieces more, all it would do is add on another fraction. So I think this is a pretty smooth deal. I don't know who came up with this. I don't think the book says. They didn't really get much of a credit. I feel like this should have been named after them. This shouldn't be called logarithmic differentiation. This should be named after the person who invented this. Because if you had to do these derivatives with like product, quotient, chain rule, combination moves, it would be absolutely absurd. But that is absolutely simple. Like this is that's the scariest looking problem you have ever done in math. But the actual effort level to achieve that answer is very, very low. It's not exactly lines on the Z's difficulty level, but that's not that hard. Is the homework harder? Maybe, I don't know. But the basic concept of these is a pretty nice upgrade onto our skills. There we go. Homework off of this, it's the same page. It's going from 41 to 52. It's almost easier to do the hard ones. Like, if I go back now and do this to you, It's almost like too easy to seem like it's even worth the effort to do this process or whatever, but, let me see, 41 to 52. I mean, change all the roots into halves. I don't see anything too extravagant. One thing I see that you might have forgotten how to do, let's say I throw on here an e to the 5x. Now I need to add on a fraction that would have e to the 5x. Do you remember how to do that as derivative? It's been a couple days.
Is it e to the power times the derivative of
It
that?
is e to that same power
Times the derivative of that.
which is,
5.
and then could you upgrade that? Just 5. So I see at least, I see one thing sneaked an e in there. If they sneaked in some trig, cosine 7x, I'd have to subtract that fraction because it's on the bottom. Cosine 7x, derivative of cosine 7x,
Science.
negative sine 7x, but with a 7. Best answer for this, sine dividing cosine still continues to be tan 7x. So maybe we get a piece like that sprinkled in. Well, I don't see too much going on here that's really like super Nazi. Give it a whirl, but 41 to 52, that's the name of our game. You want some even answers to confirm your success? Do you need even help? Do you need a lot of help? Do you need anything
Should
from
I
the first,
stop
like, 40?
recording now, or is it time to stop
Yeah,
recording?
we're done recording.